Hello and welcome. What you see here with me are two bottles. One is almost full and another is almost empty, you can say, or you can say it's little bit inside. Why am I holding these bottles? Because today's topic will have examples on these bottles, and it's quite easy for understanding when I put some examples like this, and I hope this kind of examples will help you understand certain terms or certain scenarios which we face in aviation. Because for those of my friends who are not from aviation, sometimes they might face it difficult to understand certain scenarios, certain situations, or certain terms. So these kind of examples help them a lot. So what is today's topic? Today's topic is about fuel jettisoning or fuel dumping. And why did I choose this topic today? Because if you have seen my post of yesterday, one of the Turkish Airways Boeing 777, that is Boeing 777-300ER, that aircraft, in the act of takeoff or while it was taking off, one of its engine did a malfunction, or if you go more technically, the compressor of that engine got stalled. Due to that, they had to shut down the engine, the left engine, and they had to go for a holding pattern over Istanbul for almost 4 hours, and they landed after that, of course safely. There was no injury, and everything was smooth afterwards. But the thing is, in the act of takeoff, they faced in-flight shutdown, that is IFSD, and they went into a holding pattern. So what is the connection of jettisoning or dumping with this matter? What happens, why they went on to holding pattern, we'll discuss that. When one aircraft is heavy and it cannot land immediately on a runway, that time the fuel needs to be dumped or fuel needs to be jettisoned so that the aircraft can land safely. Now in yesterday's case, whether the pilot did some jettisoning or dumping of the fuel is not yet clear, or we do not have information about that, but there are chances that he might have gone for certain jettisoning, or he could have gone for certain jettisoning, because I cannot say it clearly he went for that option or not, but he was in a holding pattern. That means instead of jettisoning, he wanted to burn up the fuel in air, so that after burning up the fuel it will become light and it will come to land. So now coming to our topic today, jettisoning. We'll see what jettisoning is, what is its scope, and why do pilots do, and who are the person who help the pilot achieving this goal of jettisoning. Now about the examples. As you can see, these two bottles, this bottle, take this bottle which is filled completely or almost full. Treat this bottle as an aeroplane during takeoff. That means this is the fuel, this is the ATF fuel inside that aeroplane. Okay, and this is the aeroplane when it has exhausted the fuel. You can see here, it's little bit is there, whatever is required, but he has already, the pilot has already consumed, or in this case the aircraft has already exhausted the amount of fuel. Now, if you see these two bottles and take them to a 7-story building and drop them from a 7-story building, what do you think, which bottle is going to be damaged more? Of course this one, because it has got some weight, more weight than this one. This is lighter. Sometimes this can be empty or very less also. So damage on this will be very less, and damage with this bottle which is filled with water, or you can say filled with aviation turbine fuel, if you treat this as an aircraft, then the damage to this aeroplane will be more. So this difference you have to understand here. Aircraft with less fuel, aircraft with full fuel, fully loaded. What happens? During takeoff, the aircraft has a planning. Suppose it is flying from London to Singapore. Okay. Now it has a planning and it will take that much amount of fuel so that it can fly from London to Singapore in one go. It doesn't need a stop. So in that case, the fuel of the aeroplane will be, the tanks of the aeroplane will be completely filled. When in this condition it took off from London and it's going to Singapore, but when it reaches to Singapore, by that time the fuel quantity will be this much. It's very less. So it's landing in that condition. Imagine it took off fully loaded and it's landing in this condition. So the damages or the stress that will be imposed on the aircraft while landing is less. That is why the fuel dumping or jettisoning is required when you do not land in this condition. That means you are taking off as a fully loaded one, and while taking off you faced certain problem, maybe some engine problem, one of the engine got shut down, or any such thing that forced you to come back to the same airport or a nearest airport. While you do so, the weight of the aircraft will not allow you to land there, because if you try to land with that amount of weight or that heavy, you will damage the structure of the aircraft. So here there are two terms. One is called MTOW, that is maximum takeoff weight. Now this is MTOW. Now it is flying in this condition. Another term is maximum landing weight. That means this maximum landing weight is a design weight assigned to a particular aircraft or any aircraft. Suppose this aircraft, this is a 380. Now this aircraft has a design weight for landing. That means if the design weight is more than that, the aircraft cannot land. Let us give examples in figures. Suppose one of the aircraft, the design landing weight is 15 tons. Take example 15 tons. And the takeoff weight is 20 tons, because when it takes off, that time it is fully loaded with cargo, fuel, passengers, everything. So it is 20 tons. But landing weight is, what did I say? 15 tons. Now, when the aircraft is landing, it is 20 tons and immediately it has to turn back or land back. definitely that 5 ton difference is not yet consumed. That 5 ton difference fuel is not yet consumed. So can it land? No. If it tries to land, it will definitely meet with accidents which will be sometimes non-recoverable. There will be structural damage to the aircraft. The landing gears might get collapsed. These landing gears might get collapsed, or the landing gear and this wing, you can see this one is, these are wings. It can give some kind of impact on wings, or maybe the fuselage. Anything can happen. So the damage can happen because the maximum landing weight was 15 tons for this aircraft, and it exceeded that, because when it took off that time it was 20 tons and it could not burn off that much of fuel. When it could have burned up that much of fuel, when if it would have flown, suppose if it would have flown to Singapore, or if it would have gone to the destination, it would have become like this, which is less than 15. Suppose 15 tons is somewhere here, half mark. See how much it has consumed here while flying to Singapore. So it is safe to land. It can land safely, or at least 15 tons it can land safely, but it is fully loaded now. In that condition, what is the pilot going to do? There are options. Suppose the pilot is not in a hurry. It can burn up the complete fuel by making a holding pattern. Like yesterday's thing, the pilot went into a holding pattern for almost 4 hours, and in that process it did burn the required amount of fuel so that it will come below the 15 tons. Example, I am giving you example, and it can land safely. It was non-emergency, so he stayed in the air for that many hours, like 4 hours in this case. Suppose there was fire inside the cabin and it could not be put off, or the fire is continuing. That's an emergency. So the aircraft needs to land. So in that condition, what is the pilot going to do? The pilot has to jettison or dump the fuel, the excess fuel what is here, he has to dump the fuel. I mean, it will go. Okay. When it comes below that 15 tons, or the design landing weight, in this case, like I told you, there is a design landing weight which is given to this aircraft, because they have tested during the manufacturing or during the design process that if this aircraft lands at this weight, nothing will happen to the aircraft or the structure. So that landing weight has been assigned or given to the aircraft, and after jettisoning, the aircraft has to come to that weight or below that so that it can land safely. That is why the pilot needs jettisoning. I hope you understood about jettisoning. Okay, fine. Now, where can he do the jettisoning, and what are the height requirements? What are the criteria? Can he do at any height? Can he jettison or dump the fuel at any height? No, there are certain regulations or guidelines for this. He has to follow them. Then only he can do the jettisoning. If you see the general guidelines, whether it's Boeing or Airbus, they have the altitude regulations or altitude requirements of minimum 6,000 feet above ground level. 6,000 feet altitude or above ground level condition is required to start dumping the fuel. Why? Because if the aircraft, and if it is above 6,000 or 6,000 feet, they have studied that the dumping generally happens from the trailing edge of wings. This is called trailing edge. If you see this one, this is a trailing edge. Generally, they keep a duct here near the trailing edge so that from the wing, as you can see here, from the wings, the fuel can be dumped using a dumping valve. So what they have seen is, from the dumping point to the ground, the 6,000 feet is enough so that the fuel can get evaporated or dissipated during the process. It will not touch the ground because ATF, it's a fuel, okay, and it is harmful for the harmful for the cities, or harmful for the people under it. It should not touch the ground. That is the idea. So one condition is 6,000 feet. What are other conditions? Can it while it's in takeoff phase, suppose there are other aircrafts in and around, can it start jettisoning the fuel or dumping the fuel? No, it cannot. The regulations here again say, this is the aircraft. The aircraft from the nose to 10 nautical miles, from the wing tip to 10 nautical miles, from other wing tip to 10 nautical miles, and from the jettisoning point here to 50 nautical miles. This is the envelope. Front 10 nautical miles, side 10 nautical miles, right side 10 nautical miles, back side 50 nautical miles. This is the air space. Imagine this in air. It's a horizontal air space. That area is to be given free to this aircraft or aeroplane to start dumping. If that is not respected, the fuel can contaminate other aircraft or aeroplanes around it. That is to be given. Okay, this is horizontally. Vertically also there is a separation minima. We call it vertical separation minima. This term we'll discuss on some other day, but now for today you try to learn it or try to understand. Vertical separation is the vertical distance between two aircrafts flying in the same airspace or together. When they are flying, two aircrafts are flying, they can fly. So one aircraft and other aircraft, that vertical separation, or whether it is up or down, like here, suppose these are two aircrafts flying. This separation, they are flying together. This separation is vertical separation. So vertical separation at the top of the aircraft is 1,000 feet and bottom is 3,000 feet. That means another aircraft which is flying along with this aircraft can fly below 3,000 feet, because still there is understanding that this fuel can affect the aircraft flying under this aircraft which is jettisoning now or which is dumping now. And due to similar reasons, they also want the top aircraft which is flying above this jettisoning aircraft to be at 1,000 feet, because mostly the fuel will go down. Up, some vapors can go upside, but the tendency will be that it goes down. So this is the condition, vertical and horizontal. Horizontal, as I said, in nautical miles, 10 front, back side 50, sidewise 10. Vertically 1,000 feet above and 3,000 feet below. So these are the conditions. And from the ground level, of course, 6,000 feet. Okay. So we understood the limitations. What are other limitations regarding communication? Suppose one aircraft wants to dump fuel. That means it's an emergency, isn't it? So emergency information is to be given first. Next, if the pilot or the cockpit crew intends to do the jettisoning or dumping, then at that moment they need to inform this to the ATC and take guidance from them that the area I am dumping, is it suitable? Is there any civilization, or is there any population under me? This clearance will be given by ATC. ATC will say, no, you cannot dump it here. Go to this particular point and dump the fuel there while being in a holding pattern. Because if the pilot is not properly guided, this dumping can create problems for others, which is not expected in aviation. So communication with ATC is must. And what is the assistance ATC will give back? ATC first needs to understand that what is the current situation. He needs to acknowledge that, okay, this thing has happened. And because it's an emergency, the ATC needs to inform all the stakeholders or supervisors or other department like fire and rescue team in airport or standby airport or the airport where it is going to fly. The ATC has to be in complete control. It has to, I just explained you about the separations. Now separations, how can they be maintained? They will be maintained by the ATC. The 1000 feet, 3000 feet, sidewise, front, back, all these things, ATC has to ensure this. So ATC has to separate this aircraft from the crowd of aircrafts or rush of aircraft. They are doing takeoff and landing near the airport. So this has to be sent to some isolation area. This is ATC's job. Then what else it has to do? The advice or the support, that is this particular pilot is asking, it is to be provided by ATC at that moment, because he is already in some kind of emergency. So ATC's role in this process is quite vital, because jettisoning has to happen. After that, the fuel amount will lighten and the aircraft has to land at the nearest airport or the same airport from where it took off. So about jettisoning and its limitations in and around, that be understood, like what is the nautical miles, what is maximum landing weight, and what is the design weight, all that things be understood, and this must be followed by the pilot who's in the cockpit, and also the ATC will assist. So these were all about the dumping. But how that dumping happens, I was trying to explain you here. If you see closely, you can see this. Okay, now you see these wings. In these wings, as we all know, the wings store the fuel, right? So from the wings, they make a way with a duct, with a pipeline, so that this fuel can escape easily from the aircraft or aeroplane, and they keep enough distance so that while jettisoning, or you see here, while dumping, the fuel doesn't come in contact with the body or fuselage of the aircraft body that we call fuselage. This jettisoning should not affect any of the aircraft parts. This is the design aspect which the manufacturer or OEM, they do that. But for our understanding, like where it is, this is in this trailing edge area, as you can see, and from here the dumpings can happen. Okay, so you know the location from where the dumpings happen. Is this dumping available for all type of aircrafts? Any aircraft can dump? Again, this is the question, and the answer is no. Suppose take this case. Now I was showing you this example. This aircraft, there was an aircraft where the takeoff weight was 20 tons and landing required landing weight was 15. Take another aircraft where the takeoff weight is 10 tons and design landing weight also 9.5 tons. Okay, so you see the difference. Now 10 tons is a smaller aircraft. 9.5 why they keep? Because smaller aircrafts generally they fly due to their fuel limitation, they fly small distances. Maybe you can say take Mumbai to Aurangabad, or maybe you can say Nagpur to Raipur, any such thing which is smaller distance. So in that case, the aircraft taking off and it's landing, how much fuel it will burn? Hardly 1 ton or less than 1 ton in some cases. So in that case, what is going to happen? The aeroplane manufacturers, they give the design landing weight which is near to the takeoff weight. Like in this case 10 tons and the landing weight is 9.5 tons. So only 0.5 ton the aeroplane has to burn. In such close cases, what happens? The aeroplane takes off and it found issue with the aircraft or any engine malfunction or any other function where the aircraft has to return back. The malfunction is not important. The intention of the cockpit crew or pilot is important. He wants to come back due to any such reason. He wants to turn back or land back on the same airport. Difference here, the 0.5 tons, that is acceptable for the manufacturer or the regulators so that aircraft can land back. That means in this case, the pilot need not jettison anything or it need not go to a holding pattern for burning of the fuel. It took off and it's just making a turn there and coming back and landing. So due to close difference between takeoff weight and landing weight, maximum takeoff weight and maximum landing weight, the aircraft can either burn that much of fuel while making turn, go back and come down, or make a quick holding pattern of 10 minutes or 15 minutes and come down. So in that case, the structural deformation will not happen because those aircrafts are not the bigger wide bodies or bigger aircrafts where the difference of this maximum takeoff and landing weight is too much. So they can sustain that much pressure with that fuel filled tanks or fuel filled wing tanks. So they don't need a jettisoning system. So if you see those smaller aircrafts like Airbus 320, or if you can say ATR 72 aircraft, or any such, you might have seen many domestic sector flights which are not necessarily the wide body aircrafts, or some Boeing series aircrafts also you can see. They are not necessarily equipped with this particular jettisoning system. This jettisoning system is mostly for the bigger aircrafts, and the reason you know. So for smaller aircrafts, jettisoning system may not be there because the fuel difference between landing and takeoff weight, or the weight difference between them, is very less and it is safe for landing. So you will not find the jettisoning system there. And even if this aircraft, the smaller aircrafts, land without the necessary difference in the landing and takeoff weight, many a times the design is so robust that if it lands and inspections after that, the inspections done after that, the, it is found that there are no structural deformations or there is no issues to the aircraft after the landing. So that is another safeguard, or you can say that is another protection layer for the aircraft not to be damaged. In bigger aircraft, suppose in case of bigger aircraft, where jettisoning system is there and you must do a jettisoning, but due to some reason you couldn't jettison the fuel and you must land at any condition. That means in this field condition you must land. That is happen and that is possible. In many cases we have seen, I personally have seen, it is possible, but there may or may not be damages to the aircraft. In some cases I have seen there are damages, or in some other cases the aircraft design was such it could sustain that landing, or during those conditions the technique of landing also depends. How much you can delay the touchdown process, or how skilled is the cockpit crew, that depends a lot in this kind of emergencies or in this kind of landings in crisis. That depends, that aircraft doesn't get damaged much. You can see in many of my posts in my website FL360 Aero, I have mentioned about this kind of things, about the damages and structures, where the inspections have revealed the amount of damage sustained by the aircrafts, and sometimes it is enormous. Sometimes the aircraft sections, there are different sections in the on the fuselage of aircraft. The sections, whole section get affected, and that's a big recovery process. Sometimes it takes months and months of time to recover the aircraft. So this was today's topic. It was about fuel jettisoning, how it is done, and